Hey, so last time I forgot to add the dielectric material, and let's go ahead and add that in this video. Dielectric, dielectric, and we choose domain for it, and let's put on the permittivity 1, 0. Ignore the other ones. The reason why you're seeing the X here is because COMSOL is telling us that it sees that we are using all domains here. That requires, like, especially the Bioheat one, and it requires that we select it. It's seeing that we selected all domains, but all domains does not specify where the thermal conductivity density is required. So in this video, we don't need to analyze the other domains besides the liver tissue. So go on Bioheat and deselect all the other ones, and that should take care of it. And you need to refresh it by disabling and enabling it, so no more errors. Let's go ahead and work on the electromagnetic settings here. Pull down on the equation, frequency domain, user define F. So we just define the frequency, and let's go ahead and add the power input port, and that's going to be this boundary. Let's zoom in. It's going to be this boundary into the dielectric, and type port is coaxial, wave excitation on, power in is P in, and the last thing we need to add for the electromagnetic module is the boundary condition, scattering boundary condition. It's going to be 4 boundaries we need to add. This one, control click, click, and the last one is zoom in, click, add, and okay. That's, I believe that's all we have to do for that part. Yeah, just make sure that your port is on the correct boundary, and your boundary condition is 217.19.20 as mentioned in the tutorial online. Now let's move on to the bioheat transfer equation. We need to add a heat source. The heat source is going to come from our simulation here from the electromagnetic. Select all domains. Remember that just select one on for this level, and then heat source all domain, so it doesn't matter for the 2, 3, 4. You can deselect these if you want. I mean, it doesn't really matter, but. And then under heat source, general source, dissipation, total dissipation density. Okay. Now we need to specify the tissue, I mean the blood information like density we define. Rho, blood, CP, blood, this, and then omega, perfusion, blood, Qmet is 1000. This is the metabolic generation. I believe they don't have this in the tutorial, but I mean, you can either add this or not, but I just want to be a little more realistic with my model. So yeah, just that's optional. This is up to you to decide. And let's move on to the mesh part. So in this tutorial, the easy way is basically you do the physics control mesh and select extra fine. We'll do, build all, and that'll create the mesh for you. Or you can follow the tutorial where they actually define user specific mesh option. So you can do that by right click on mesh, free triangular, under size, see element maximum here. You see, if we select user the this one extra fine, it actually has a lower limit than what the tutorial wants us to use, which is 3mm for the size, which is fine. And here you right click on free triangular and add size. Okay, and then we need to select the bound domain, and the domain is this one. That's the dielectric domain. And select the custom psi, maximum psi element to be 0.15mm, and build all. And look at this, it has about 1,000 more elements than the physics control mesh. I mean, results is pretty similar. I have tried both, so it's okay if you want to follow the tutorial online. Okay, now let's move on to the study part, which I'll leave on to the next video just in case. Just be safe, because yeah, the thing about making videos is that you want to have checkpoints. If something goes wrong, you don't have to start over again. So I'll see you guys in the next video. Thanks for watching. Make sure you're safe as you go along this tutorial.